1957 was just about 10 years after our independence, and within 6 years of that event, we had in our country, in Tumba Equatorial Rocket Launching Site, on the 23rd of November, a sounding rocket doing some upper atmospheric research. This happened because Dr. Vikram Sarabhai, I am sure each one of you are aware, a great personality, a person who has been responsible for development in so many spheres. It was his vision that when an event like space Sputnik went up in orbit, when Americans and Russians were really looking at who is more powerful, who is mightier in military domain, he was thinking of how this new technology of space can be brought to the benefit of our country. Because he was also aware that Arthur Clarke had already told that if you put an object in space at about 36,000 kilometers from Earth, and if you put it into an orbit, it takes exactly 24 hours to go around the Earth, and the object remains stationary. It's almost like a tower which is at the height of 36,000 kilometers, and line of sight communication enables 1/3 of the globe to be covered by such an object. So he was keen that this technology of space be brought to use for linking the vast expanse of our country. In 1975, he was the person who was responsible for coming up with a program called Satellite Instruction and Television Experiment, where again, by virtue of his friendship with Americans and Russian, French and German scientists, he had ensured that United States NASA was going to provide a satellite, an advanced technology satellite called ATSF. It was borrowed, brought over India, and for 1 year in 1975, ISRO conducted a program, the like of which had not been done by anybody in the world. It was called the largest socio-technological experiment, where making use of this satellite, broadcasting was reached to 2,400 remote villages of our country using a technology which you are all very familiar today, direct to home. That time it was called direct to community sets. In those 2,400 villages, you can imagine in 75, it's very difficult to reach even electricity in many of these parts. But then for 1 year, through these advanced technology satellite borrowing from Americans, the information was reached to the farmers and also to the villagers, not only about the farming practices, health practices, and even entertainment. And this experiment of 1 year convinced the government that this space technology is definitely going to be beneficial for the country. You can also imagine if you were to tell any politician that what you are talking about can be heard across the country at a time when communication was not so as good as today. You don't need much more convincing of the technology to be utilized. That's how we had at that time the INSAT series of satellites which were approved, wherein again what was done by ISRO was made use of the technology accessible to it, but conceived of a solution which is very unique, because at that time the satellite, geostationary satellite technology was making use of what is called a 3-axis spinning system for stabilizing the satellite. But we for the first time made use of a 3-axis stabilized satellite being used for a functionality what we call as 3-in-1. Meteorology, that is looking at the clouds and then trying to look at, based on the cloud patterns, looking at cyclones. Then communication, that is telecommunication and broadcasting. All these 3 independent services were rolled into one satellite, and it was conceived at that time, again because of the necessity. We could not afford 3 independent satellites and 3 independent launches. So for the first time in the world, a satellite which was conceived like this had to be built again at that time, since we did not have the necessary infrastructure. We got the first round of communication satellites built by an American firm, the first generation which went up in 1981. But from the second generation onwards, all the communication satellites are built within the country. So this 3-in-1 satellite again enabled India to cover not only the broadcasting reaching out to the entire Indian landmass, the telephone connectivity improved, and even in terms of meteorology, availability of weather information on cyclone, this was improved. Then while this activity was going on, we also had the activity of what is called remote sensing, where the idea of making use of observation capability from space. The advantage of space is that you don't see any state boundaries or national boundaries in that. You can look at the entire phenomena, what is happening in the Earth's atmosphere and Earth. So because of this, the observers, if you put in these satellites, you can look at what is happening on Earth, whether it is on the crop, or we were also able to identify the locations where we need to drill bore wells for getting water. Using this technique, the services that was provided was almost like 4 lakh bore wells were drilled over a period of 3 to 3.5 decades with a success rate of more than 95%. You compare that with any other event which had a 50% success rate. So the idea of providing bore well drinking water was one of the things that was being done using this space technology. Then the other thing that was there was again looking at the state of forest. The biennial forest survey, the forest survey of India was enabled to do the surveying of the forest cover of the country. Then crop forecasting over a period of almost 3 to 3.5 decades based on the observations from space. The center which has been set up a couple of years back in Delhi called Madanobis Crop Forecasting Center today provides to the government ahead of harvest the yield in almost about 8 different crop types: the rice, wheat, sugarcane, groundnut, cotton, and many of these crops. What is the yield ahead of the harvest? Then the information that was being provided in communication, apart from the telephone connectivity, which I am sure some of you would have experienced during your earlier days in the 70s and 80s. If you wanted to make a call to anybody near or dear to you, you have to go to a central telegraph office, make a person-to-person call booking, and if you are lucky that day, the call will get through. Otherwise, you'll have to repeat that and go all over again. The whole scenario changed because the communication capability coming from the satellites enabled linking not only telephone connectivity, but also the VSAT connectivity, the very small aperture terminals, which is the backbone of many of these stock exchange activities as well as banking activities. These were all possible from the space technologies communication satellites which were developed. Now, one of the key things that happened during the initial days when Vikram Sarabhai was trying to get the system going in India is a very interesting example of how things actually played out. Like I said, on the 23rd of November 1963, the first sounding rocket was launched from Tumba. For doing that, Dr. Sarabhai had to actually convince the fishermen through a priest in a church in that beach. So he went to the priest, requested him to convince the fishermen that they should vacate this place so that if they do that, the country's scientific technological development would benefit the people someday ahead. And the priest could convince the fishermen, and he told them that if you vacate this place now, the country will benefit. Now, true to that, from 1999 onwards, ISRO with its observation capability from space, looking at thermal fronts and also looking at the color of water, from that chlorophyll, the food for fish. Then from 1999 onwards, through an entity of Ministry of Earth Sciences today, the Indian National Center for Ocean Information System started providing to the fishermen the location to go for fishing. This was called the prospective fishing zone identification. And this alone saves to the country between 15 to 20,000 crores a year, because the fishermen spend that much less on the petrol and diesel, because they don't have to search now, they can go directly to the specific location. Now with our recent navigation satellites in orbit, what we have done is we have gone one step ahead on this, and today the gadgets will be very soon, the experiments have been conducted already, gadgets are available which will enable the fisherman in his mobile, in his local language, he will be told not only about where he is in the ocean, where he has to go for fishing, plus he can also be warned of any atmospheric event that could affect whether the roughness of the sea or the sea state roughness or any impending weather danger, he could be alerted. And this happening in his mobile, in his local language is possible with the satellite communication and messaging service and Earth observation capabilities that have been generated. So in a way, what was promised in 1960s actually became true 99 onwards, and today it has gone one step further. Now, apart from this, today we are also in a position to provide to the country, based on a series of very high resolution satellite, the information to urban development and also for many of the rural development activities. Today one of the things that have happened is, like I said earlier, Mahalanobis Crop Forecasting Center started operating about 4 years back or 5 years back. It took almost 3 to 3.5 decades of effort of ISRO to convince the agriculture department that they should own this setup and start operating. Whereas some entities like Forest Survey of India, they started very early. Over a period of time, it's not easy for you to go and tell somebody that the work you are doing can be done differently. If you adopt a new technology, the natural reaction would be, who are you to tell me, I know my job better. So it was not easy to convince people that using space technology you can do things differently, you can do faster, you can do better. But today, with the kind of the support that the government is giving, while in the initial 3 to 3.5 decades, we were able to convince maybe about 15 to 18 departments to adopt the space technology usage for their work. Today we are working with almost 60 departments, and each of them are finding the use of space technology in their activity of monitoring, planning, and also evaluating the activities. Just to give you a few examples, one of the things that happened in Andhra Pradesh is, while they were building the housing for people, so for actually dispensing the money as the building construction activity goes on, by making use of the geospatial technology and the mobile application tools, today a person who is constructing, he can take pictures of the corners of his building as it is going on, and this information straight away gets registered through a platform called Bhuvan, and the government is able to actually see the progress that is happening, because two things are guaranteeing this mobile's data. One is the time at which the event is recorded, and the position, geospatial position, latitude and longitude. These two things get incorruptibly recorded, and as a result of that, it's easy for people to monitor. And today this application is, we have built more than about 90 mobile applications which are being used by various state and central government departments in monitoring and planning their activity. One of the things that also happened is, again, almost I'm sure you are familiar with the MGNREGA, that is the Mahatma Gandhi Rural Employment Guarantee Scheme. In that, the country used to spend maybe 30 to 40,000 crores a year, but out of that, what actually has happened, whether there was a proper registration of the activity that was done, was a question mark. When the government wanted to make sure that they have a credible mechanism for recording this, we started working with the Ministry of Rural Development, and today, from August last year, about 2.5 crore assets have come into the database, and any citizen can see what is the event or what is the activity that has been done under MGNREGA. There are a host of attributes which have been collected by people and put on the web, and how the progress is happening and what is the actual details of the assets. these have come into the database. Here again, the much of this activity could be done without major new investment, because whatever ISRO was doing in terms of geospatial technology activities of Bowen platform and then the mobile applications has been used, and the rate at which the assets are increasing is almost 1 lakh a day now, and more than 2.5 crore assets have come into the database since August last year without practically spending a significant amount of money on the tools that are being used. And similarly, whether it is for monitoring how the benefits of the whatever water recharging schemes that are there and various mechanisms which have been adopted by the government. And today we are also providing to the government every 10 to 15 days surface water map of the country of water bodies, and this also is being used to provide second or alternative livelihood to the fishermen in the inland fisheries, because water bodies which can sustain water for periods of more than 6 months get identified, and tribals are being provided opportunity to make use of such water bodies by the various central government departments. And also governments like Telangana and Andhra Pradesh have come up with missions where in addition to this surface water information, they are also actually making use of in situ observations of water depth and other parameters to manage water resources for that state. Now, while all these capabilities are coming up by building satellites and the launch vehicles, what ISRO has been trying to do is it's trying to make use of the technology that is accessible to it and make the best use of that accessible technology, and what is not accessible has been developed totally indigenously. You can imagine when the 23rd November the first sounding rocket went from India, the entire thing came in the form of a kit, you can say, a kit which was assembled, a set of people got sort of first-hand working experience of that, and like I said, this was done in a church building. But in 2013, when we launched our Mars mission, the entire thing, the launch vehicle, the satellite, the instruments on the satellite, the complete thing was indigenously realized. And over a period of time, the satellite launch vehicle, starting from a simple SLV, we went on improving our capability to Polar satellite launch vehicle, very quick in responding to the requirements of the user group. One of the companies which put 88 satellites in this particular launch vehicle actually was an American company which was trying to build a capability of 200 plus satellites orbiting in space. The purpose of that is at 9:30 a.m. in the morning, every day, the entire globe is being imaged, and this image, you can imagine, day after day, if you are covering the same region, you can come up with large number of chain studies and can provide huge amount of inputs to various activity. So they were looking for an opportunity to put a large number of satellites in one mission. So when they started discussing with us about 60, then quickly it became 88 from their own company. And this happened because we were ready to quickly react to the requirements, make changes in our configuration, make changes in the system, and made use of this PSLV as a launch vehicle for taking this 104 satellites into orbit. Today we can put satellites into very different orbits, whether it's 600 kilometers or 300 kilometers, change and these scenarios. And then you also need to remember that launch vehicle technology, by virtue of its very nature, is a technology which is not accessible easily, and the things have to be learned hard way. And we, over a period of time, made use of the industry, and in this I definitely need to actually place on record the contribution of a large number of industries, which at the time they were also very clear that it's not easy to make profit out of this business, because the number of launches that we were doing was very few, far in between, and then they had to do a lot of effort in making sure that the components work without failure and large yield will be low. Taking all this into account, but still they were ready to work with us, and over a period of time, now we were also able to support them, and today more than 500 companies which are producing many of these, whether it is chemicals or fabrication activities or electronic fabrication activities and assembly activities, they are able to contribute. But today we have also reached a stage where in our own country now, by virtue of what technology we have built, we are looking at increasing the pace of work, increasing the number of launches per year, which not only becomes viable to the industry, but they can also start looking at making it, they can start thinking of taking a pie out of the global space market. That is another possibility, and in fact today we have, along with FICCI, a 2-day seminar which is being organized to make sure that the capability that is being built in the country can actually take a part of the global market and over a period of time become a significant player. But before that, let me continue my narrative on what ISRO has been trying to do. So the PSLV vehicle has been developed and it has become very internationally sought after vehicle for launches. Same way, if you look at in the geostationary satellite launch vehicle, that is, you need, when you want to put satellites into geostationary orbit of 36,000 kilometers, you need much more capability, and for this we had to make use of liquid oxygen and liquid hydrogen cryogenic systems and cryogenic engines. When we started the initial activity, the idea was probably Russia was going to provide technology transfer and actually provide an opportunity to build this capability in the country. But very soon the scenario changed, geopolitical forces ensured that technology transfer did not happen. But that was a blessing in disguise, because we started working completely for indigenous development of cryogenic engine, and today you will be happy to know that the GSLV Mark II, we have done 4 successful consecutive launches using our indigenous cryo engines, and early this year we also had GSLV Mark III, which makes use of another different cryogenic engine, different capability, and this can put up to 4-ton class into geostationary transfer orbit. Here, to appreciate the difficulty of this engine, the fuel, both the liquid oxygen and liquid hydrogen, they are at cryogenic temperatures between 20 Kelvin to 70 Kelvin, and then if you have to store, before the launcher makes use of this as a fuel, it has to be stored for a finite period of time, and then for ensuring that the temperatures do not go up, and then from this liquid stage you convert it to gaseous stage, drive it through the engine, and the engine has to be kept cold. You will realize that if for about few tens of milliseconds or few hundred milliseconds, if you are not actually cooling the engine, the entire engine melts away. So it's a very difficult technology of dealing with large number of different materials, building up such a capability, and by virtue of what ISRO has done along with the industry, a large number of industries, today we have 2 independent types of cryo engines on which we can say we have developed a significant amount of technological capability. And last 2 years we conducted more than 200 tests on the new cryogenic engine, and with the successful testing of these engine at different levels, we also demonstrated by putting one of the communication satellites of 3.2 tons earlier this year using such a capability. Today what we are planning is these GSLV type of vehicles, we are going to plan almost 2 to 3 per year, and PSLV about 8 to 10 per year in the next 4 to 5 years. We are trying to build such a capability. We are trying to get the necessary approvals for all these launch vehicle activities, so that over a period of next 5 years, almost 60 launch vehicles will be going up. While you are building these capabilities of both the launch vehicles of PSLV and GSLV, what we also need to remember is world is not remaining stationary. It's moving ahead. It is doing work at such a pace that disruptive new technologies are coming up, and these technologies can make things so difficult that whatever capability that we would have built would become commercially not viable. So you always need to make sure that you are working on newer technologies and capable technologies which reduce the cost of access to space. It is in this context that last year you also saw that we did a couple of experiments on reusable launch vehicle technology demonstrator, wherein we were able to bring back a wing body which was fully designed in the country, which operated at a very high Mach number with temperature regimes which are very high, and which also required not only large amount of simulation using computational fluid dynamics, but also wind tunnel tests in the country. And using all that, we were able to demonstrate first step. Of course, it was a baby step, but it's an essential step, where a reusable launch vehicle with special thermal tiles protecting it from the friction of atmospheric re-entry, and then virtually landing it on water by doing the control mechanisms of the wing body. That was demonstrated. And similarly, we were also able to demonstrate an air breathing propulsion system which picked up oxygen from the atmosphere, and for about 17 to 18 seconds it demonstrated a sustained flame presence of hydrogen and oxygen. And this is also a very important step. Very few countries have achieved even that level of demonstrability, but we still have a long way to go in that. And beyond that, we are also looking at how to reduce the toxicity of some of the chemicals that we are using in the propulsion system. We are working on what is called a semi-cryo engine, which makes use of kerosene and liquid oxygen as the fuel for the launch vehicle. And then in terms of the satellite capabilities, while today we have about 42 satellites in operation providing Earth observation, including very high resolution imaging, less than a meter capability. Just within last 1 year, we launched 3 such satellites, and very soon, end of December or early January, we will have a 4th satellite of that capability with multispectral and panchromatic, very high resolution imaging capability, which can provide huge amount of input for many of the urban studies as well as planning activities, and also for strategic activities. And then the navigation satellite again was a very unique study, where you are familiar, the GPS system, whether it is of America, Russia, or what Europe and China are planning, is a constellation of 24 to 32 satellites. We came up with a 7 satellite constellation. Of course, the use of this is limited to India and surrounding India, about 1500 kilometers. But like always, the ISRO's prime aim has been to address the specific problems of the country first and then move ahead. So today we are able to actually provide to the country, using an independent receiver system, an ability to locate yourself, and also, like I said, the messaging system on this is also able to provide to the fishermen, and Internet of Things, many capabilities that are there on this. Then we also are able to provide to the country a system called Gagan, which ensures that in this part of the globe there was a void for global aircraft carriers carrying satellite-enabled receivers. Today, over India, the Director General of Civil Aviation has certified the use of this service, and any aircraft which is going to be registered after 2019 January has to necessarily carry a receiver making use of these capabilities, and it is able to use this service for en route planning and also for precision landing. And we are also working on systems which will enable with what is called pseudolights for a large number of airports in the country which are going to come up for turboprop engines or other smaller locations. The instrumented landing system becomes indigenously available by making use of navigation system and also pseudolight system. So primarily what another one major important area where ISRO has made a difference to the country is in the area of cyclone tracking and prediction. And today you are all quite familiar, last few super cyclones, we were able to provide through the India Meteorology Department necessary information to the disaster relief agencies so that they could evacuate people well in advance, and loss of lives which used to be in the range of tens of thousands during super cyclone times and earlier decades have practically reduced to less than a single digit, and even that because the people do not pay heed to the advice that is given. But otherwise, today both in terms of cyclone tracking and cyclone intensity prediction, a significant amount of capability exists in the country. And one other thing that has happened is not only have we been able to provide information to our country, but also we have built some satellite system like scatterometer instrument on SCATSAT, which provides ocean wind vector, which is an extremely important parameter for atmospheric weather computations globally. All computational models require this information on a continuous basis. Today we are providing to the global community within 180 minutes of acquiring the data, and this is very well appreciated globally. Then apart from that, we also have microwave imaging capability, which is like glass is transparent to us, we can see through the glass. Our country is covered with cloud during the period of monsoon between June to September, and then from space when you want to look at in optical or infrared domain, cloud is a hindrance. But using microwave, you can see through the clouds like glass is transparent to us, so you can make observation, and we have a number of microwave instruments which have been developed. So the technology development continuously is happening, and apart from these things, we also did Chandrayaan mission and the Mars mission. Chandrayaan mission, you will all be very happy to know that though this probe on the Chandrayaan was done only in 2008, many years later than man landing on moon or a large number of probes going around the moon, the credit for discovering the process of water molecule formation and presence of water on moon, the credit goes to Chandrayaan 1. And in the same way, the Mars mission, again, if you look at the significance of this, while more than 50 attempts had been made with 40% success rate, we were able to do this in a much shorter period using our own PSLV. And what was demonstrated was that in a maiden attempt, a single country in its maiden attempt was able to put the Mars orbiter satellite around Mars. And to appreciate the complexity of this mission, if you are told on the 5th of November 2013, when we launched the satellite on the PSLV, the task cut out for that satellite was, it had to travel for about 10 months, a distance of 600 million kilometers or 60 crore kilometers, and at the end of that time, on 24th of September 2014, morning 7:30 a.m. to the second, if you imagine a cube of 50 kilometers in space at a finite location, this object had to be inside that location at that second. If it were not going to be there, then the mission would have been a failure. And what kind of forces can actually deviate the satellite during this 10-month period, if you look at any mishap that can happen during the trajectory itself, plus the fact that the sunlight falling on the satellite produces a small force because pressure, the sunlight falling on the panels of the satellite or on the surface can produce a small force, and that force can deviate the trajectory of this satellite beyond that 50 kilometer cube. So what was required is you had to continually track this object, locate it, and provide necessary impulses required for this satellite to go and get inside that cube. Only then it would have been a successful mission. And it was for the first time that we were going to take an object beyond the Earth's gravitational field. Even the lunar mission, what we had done, was within the Earth's gravitational influence only. So this one, we were going to take it outside the Earth's gravitational influence and make it happen. So to the credit of the people who did the design and then worked out the system, they were able to conceive of the autonomous capability required for this satellite. Because again, probably each one of you, when you turn on a computer or turn on your laptop, when it takes a few hundreds of milliseconds to boot up, sometimes you feel fidgety. Why is it taking so much time? But then if you remember here, if you send a command to the satellite, it takes almost 14 minutes for the signal traveling at 3 lakh kilometers per second to reach the object, and then another 14 minutes to come back. That means if you want to know what has happened, the result of the command you have given, you have to wait almost half an hour. So obviously you cannot wait for such long periods for correcting any mechanisms or failures that occur on the satellite. So you have to build an intelligence into that satellite in such a way that it is capable of recognizing the faults, it is capable of correcting that and going ahead. And also it was for the first time we were going to encounter in the satellite, periods like almost 2 months where there will be no communication possible between the satellite and the ground station. That again is easy to visualize because you know that while the stars do exist on the sky, we are unable to see them during the daytime because our sensor gets saturated with the sunlight. Same way here when the ground antenna looks at the satellite, if sun comes in the field of view of the antenna gets saturated and it's not, even though signal is coming from the satellite, it cannot recognize them. So such periods by conjunction of Earth, Mars and the satellite happens once in a year, and then during that period, almost 2 months, you have no communication. So satellite has to be built with autonomous capability to deal with such eventualities. And till though we initially thought we had a system designed to work for about 6 months, because we were expecting during the traverse period of 10 months, we would encounter many difficulties, and also the launch vehicle and the satellite did not have enough fuel for doing corrective action in case problems occur. And so we had just enough fuel for the satellite to reach the Mars orbit and then go around it for 6 months. But as the events turned out, we did not have to spend any fuel before any loss of satellite orientation or control. So even today we have enough fuel for the satellite to go around for many years. And we expect the satellite to continue to provide very useful information on many of the payloads that are there. But what this actually shows is that no matter when you are doing, if you take innovative approaches, you can take an approach which is different from what others have done. You can make a difference to the system. You can, for the first time, it was clear in the global arena that you could do interplanetary missions at a very low cost. What this did is, it not only enthused the people within the country, the student community and the entire Indian community, that no matter how difficult the situation is, whatever the situation that exists in our country, it is possible to make things happen. It's possible to make things happen and make the world turn around and look at you. So whether it is the Chandrayaan or the 104 satellites in a launch or the Mars orbiter mission. And one more important example I want to give is AstroSat. Here again, it's a satellite, a space science satellite, which was built, not all instruments were built within ISRO as an organization, because one of the prime objectives of ISRO is actually to try and build capacity in the country. So we enabled a number of academic institutions to build payloads, telescopes in far ultraviolet and then in X-ray and in different wavelength regions. And this particular AstroSat satellite already has made a huge impact internationally because it carries in the far ultraviolet a resolution which is 3 times better than the best available in the world. And today this is considered as one satellite which can do transient celestial object studies better than anything else that is available. So it is possible for us to make things happen very differently. It's possible to overcome whatever difficulties that exist and make things happen where the world can turn around and take a look at you. That is what ISRO has been able to demonstrate, and all this happened in the academic institutions of the country. And just a couple of months back, we completed 2 years of operation, and the entire data set has been made available to the research community. Not only that, this satellite is provided as an observatory to the researchers. Not only about 90% of the observation time is provided to the Indian researchers and 10% to the foreign researchers is being provided on this. While today we have, like I was telling, what we have done is we have tried to make the best use of technology accessible to us, look at how we can address problems differently from what is being done so far, find solutions to that. Today we are also in a position to actually engage a huge number of academic institutions and students for doing work using the activities that we are doing. Recently in Karnataka, in one of the institutes, about 300 students and 30 faculty staff are making use of the geospatial technologies and tools developed by ISRO to provide to the collector of a taluk an analysis on the complete assets of the villages in that taluk and what are the shortcomings and difficulties that exist in planning the activities. And in the same way in Rajasthan, we have 2 districts which are completely covered on a program called Space-Based Information System for Decentralized Planning. So we are trying to engage academic institutions. We are also trying to bring in a new capability of software development. Again, many of you are quite familiar. Today, while India is considered as a very strong base for software development, if you look at many of the industrial software that are used, whether it is in structural analysis, Nastran, Patron, etc., we make use of the software available from outside and pay huge amount of money in maintaining and running costs. So we are trying to make a difference to that by providing a software called FEAST, Finite Element Analysis for Structure and Thermal, which has got a free academic version, an industrial version and a professional version. And every year we are conducting an event in December, January, where the student community and the professors can come up with an addition to this module, and then we are releasing a newer version. Same way in computational fluid dynamics and in many other areas, we are trying to bring in a new way of enabling the people in our country to make a difference in the area of software development. So if I keep telling, probably I can go on and on indefinitely. So probably I'll come to an end of the presentations what I'm planning to give. So primarily what I can say is ISRO has tried to make the best use of this space technology, and it is looking at space as a system, space technology as a system for addressing specific problems in our country, and in a significant manner we have been able to do that. And today we have reached a level where we have about 42 satellites providing service, but what we need probably is more than double this number, and for that we need much larger number of launches to happen. So today we are addressing these problems. We are trying to increase the pace of work. You would have seen in the last few years we have done almost 5 to 6 launches of PSLV, and we are trying to increase the GSLV launches and the new capability we are bringing in. And in the next 5 to 6 years, we want to make sure that at least we will have about 60 to 70 launches of taking place. But all this is still only meeting our own requirement. So if the capability that is built in these systems have to make use of the country has to make use of it and provide an opportunity to capture a portion of the global space market, then we need to have a bigger industry participation. And like I said earlier, while the numbers were not attractive in the earlier era, today we have reached a stage where it is not only attractive, it can become attractive, but it can also become an opportunity to capture a portion of the global market. And it is in this direction that we are trying to work, and we are trying to improve the capability that we have. We are trying to build in a system within ISRO which has 4 primary verticals. One is the space infrastructure, that is a complete set of satellites and systems in space which provide a capability of observation, communication, navigation, etc. Then launch vehicle space transportation system, which carries objects from ground to space. Then applications activity, where the entire set of information is being brought into use in various activities of state and center. And then capacity building not only within the organization but also within the country, both in academic and industrial areas. And it is in this context that we are trying to give greater and greater emphasis and greater importance to these developments. And what you are seeing, many of the things, is a result of such effort. So today we are also looking at a mechanism where a joint venture between ISRO and a consortium of Indian industries is, we are trying to make a system, come up with a system which, after due approvals from the government processes, should be able to put the first launch vehicle from our Sriharikota launch site by 2020 end or 21 beginning, where the satellite could be launched by a polar satellite launch vehicle realized through such a joint venture system. And we are also trying to open up more and more activities what we are doing within the organization to the industry. And not only that, we are also trying to look at how to actually make the industry do some work which we ourselves are not doing. Just to give you an example, today there is a company, a startup company in Bangalore, which is working on a contract which we have given to them to develop a microwave thermal thruster, an activity which we ourselves are not doing in the organization, but it can become a game changer in the future. It makes use of water as a propellant and provide a thrust capability, electric propulsion type of thing, which can make a difference. In the same way, we are also trying to come up with mechanisms where the industry, if it has got some right ideas of making things happen, how to enable those kinds of things either as part of a payload or a payload itself carried on a satellite, how it can be done. So we are looking at many of these mechanisms, but you would also appreciate that being a full-fledged government organization, between the intentions and reality, it could take time, no matter how hard you try. But what we believe is, if you keep trying, definitely it will happen. If not today, tomorrow. That's what we have been able to show over a period of time, making use of the resources made available to us. Again, just one small introduction. Today, if you know that the entire amount of money what the Indian space program has spent right from its inception till today, if you add up, it is fraction of what NASA or USA spends in 1 year. So you can imagine the kind of difficulties that one could have in making things happen. But definitely what is shown is, if you work as a team, if you make up your mind, you can beat all kinds of odds, move ahead, and it is teamwork and then working together that makes a difference. And I'm sure with the FICCI's initiatives and then the people working as in the industry also, once they appreciate what is there, today it may not give you immediately, but very soon it's going to give huge returns. I'm sure many of you will take up more and more activities for space, because space is a new frontier. You would have already seen that there are large number of companies internationally, space companies outside governments have started entering into space business, and there are governments which are giving licenses for companies to do space exploration. So things are changing at a rapid pace. It's only those who are able to adapt to the change and move ahead will survive, and the rest will fall way behind. Thank you very much.